Alright, so this is the third live session on the course. This is the third live session on the course Soil Mechanics Geotechnical Engineering 1, and today's topic is soil compaction, seepage, and permeability. So I'll be sharing the screen right now. Is the PPT visible? Is the PPT visible? Hello?
Yeah,
Okay. Okay, three people are there. Okay, I start the class now, and like the previous weeks, I'll be dictating few questions, MCQ, MSQ, true, false, and along with numericals. After that, I'll give you some time to solve those questions, and after you solve, I'll be discussing the answers with you. Okay. Okay. So I'll start. Soil compaction, seepage, and permeability. The first question is: factors affecting compaction of a soil are. The factors affecting compaction of a soil are, your options are water content, soil type, compaction energy, or all of these. What are the factors that affect compaction of a soil? Water content, soil type, compaction energy, or all of these. Next question. This is a MSQ, multiple select question, so more than one option might be correct. For a same soil type, the effect of heavier compaction is 2. For a same soil type, the effect of heavier compaction is to, the options are decrease the optimum moisture content or water content, decrease the maximum dry density, decrease the effective shear stress, or increase the maximum dry density. What is the effect of heavier compaction on a soil? What does it do? It decreases the optimum water content, it decreases the maximum dry density, it decreases the effective shear stress, or it increases the maximum dry density. For the same soil type, the effect of heavier compaction is 2. The options are decrease the optimum water content, decrease the maximum dry density, decrease the effective shear stress, or increase the maximum dry density. This is a multiple select question, so more than one option might be correct. And next question. The water content used in field compaction is known as. The water content used in field compaction is known as. The options are optimum water content, field water content, placement water content, or natural water content. The question is The water content used in field compaction is known as optimum water content, field water content, placement water content, or natural water content. Next question. This is also another MSQ multiple select question, so more than one options can be correct. The variables concerning the method used to compact a given soil include. The variables concerning the method used to compact a given soil include. The options are manner of operation, weight of the equipment, area of contact, or time. I repeat the question. The variables concerning the method used to compact a given soil include. The options are manner of operation, weight of the equipment, area of contact, time. Next question. The line showing dry density as a function of water content in the absence of air voids is called. The line showing dry density as a function of water content in the absence of air voids is called. The options are zero saturation line, no air voids line, maximum compaction line, or saturation line. The line showing dry density as a function of water content in the absence of air voids is called zero saturation line, no air voids line, maximum compaction line, or saturation line. Next question. In modified Proctor test, the soil is compacted in modified Proctor test, the soil is compacted in how many layers? The question is compacted in how many layers? 2 layers, 3 layers, 4 layers, or 5 layers? In modified Proctor test, the soil is compacted in the options are 2 layers, 3 layers, 4 layers, or 5 layers. Next question. This is a numerical, so write down the data very carefully. A soil sample has a specific gravity of 2.7 and optimum moisture content 16%. What is the theoretical maximum dry density in gram per cc that can be achieved for this soil? I repeat the question. A soil sample has specific gravity of 2.7 and optimum moisture content 16 percentage. What is the theoretical maximum dry density in gram per cc that can be achieved for this soil? Your options are 0.185, 1.896, 1.885, 1.785. Whoever have joined late, I think it is Venkat. Please mute yourself. Hello.
Yeah, yeah.
Please mute yourself, Venkat. Yes, those who have joined late, please write down the questions first. After I dictate all the questions, I'll give you some time to solve them, and after that, I'll be discussing the answers one by one. Okay. So start from this question. A soil sample has specific gravity of 2.7 and optimum moisture content 16 percentage. What is the theoretical maximum dry density in gram per cc that can be achieved for this soil? Your options are 0.185, 1.896, 1.885, 1.785. Next question. Another numerical. Cohesive soil yields a maximum dry density of 1.8 gram per cc at an OMC, means optimum moisture content of 16 percentage during a standard Proctor test. The specific gravity of the soil is 2.65. Determine A. The void ratio of the soil, B. The degree of saturation, and C. The maximum dry density it can be further compacted to. This question has no options, so you're going to tell me the answer. But it has three parts. To solve them one by one, first you have to find out the void ratio, then find out the degree of saturation, and after that you have to find out the maximum dry density it can be further compacted to. A cohesive soil yields a maximum dry density of 1.8 gram per cc at an optimum moisture content of 16 percentage during a standard Proctor test. The specific gravity of the soil is 2.65. So find out the void ratio of the soil and the degree of saturation. After that, you calculate the maximum dry density up to which it can be further compacted. Alright, I hope it was clear. So this part is this up till this question it is the part of soil compaction. Then comes seepage, because today's topic has three parts: compaction, seepage, and permeability. So up till this is the soil compaction. Now we come to the seepage and permeability part. Okay. Alright. So the question is, seepage velocity is seepage velocity is your options are rate of discharge per unit cross section area of soil, rate of discharge per unit cross section area of voids, discharge velocity under constant head, or discharge velocity under variable head. Seepage velocity is rate of discharge per unit cross section area of soil, rate of discharge per unit cross section area of voids, discharge velocity under constant head, discharge velocity under variable head. Next question. Another numerical, a soil has a discharge velocity of 6 into 10 to the power minus 7 meter per second and a void ratio of 0.5. Just a moment. A soil has a discharge velocity of 6 into 10 to the power minus 7 meter per second and a void ratio of 0.5. The seepage velocity in 10 to the power minus 7 meter per second is, the options are 12.18, 18.18, 12.62, 18.62. I'll repeat the question. A soil has a discharge velocity of 6 into 10 to the power minus 7 meter per second. Discharge velocity is given over here and the void ratio is given, it is 0.5. So if you have the discharge velocity and the void ratio, how can you find out the seepage velocity of the soil in 10 to the power minus 7 meter per second? You have to calculate the seepage velocity from the discharge velocity and the void ratio. Your options are 12.18, 18.18, 12.62 or 18.62. Next question. Flow between any two points in a soil depends on the difference between. Flow between any two points in a soil depends on the difference between. Your options are pressure head, velocity head, datum head, or total head. You have to state the reason why flow between any two points occur in a soil. Flow between any two points in a soil depends on the difference between. The options are pressure head, velocity head, datum head, or total head. Next question. In a falling head permeameter test on a silty clay sample, the following results were obtained. Sample length is 12 centimeter, diameter is 80 millimeter, initial head is 1200 millimeter, final head is 400 millimeter, final head is 400 millimeter, time for fall in head is 6 minutes, standpipe diameter is 4 millimeter. Find the coefficient of permeability in centimeter per second. Those who have joined late, please write down the questions. You can write the questions which you have missed at the end when I start discussing the answers. The options are 9.289 into 10 to the power minus 5. All the answers is in 10 to the power minus 5. Those who are joining late, the class has started from 5 o'clock. Okay, write down the questions and I'll give you some time to solve the answers. Solve the questions for the answers I'll be discussing afterwards. Yes. So the options are 9.289, 10 to the power minus 5, 9.181, 9.859, and 9.478, all in 10 to the power minus 5 centimeter per second. This is the sum of falling head permeability test, and the data has been given over here. The sample length is 12 centimeter, diameter is 80 millimeter, initial head is 1200 millimeter, final head is 400 millimeter, time for fall in head is 6 minutes, and the standpipe diameter is 4 millimeter. Find the coefficient of permeability in centimeter per second. There is a formula for the falling head test. I hope you know the formula. You can apply the formula to find out the value of K, coefficient of permeability. Okay, next question. Permeability in stratified deposits, soil deposits show greater magnitude in direction. Permeability in stratified soil deposits show greater magnitude in direction. The options are parallel to the stratification, option 2 perpendicular to the stratification, inclined to the stratification, or none of these. Permeability in stratified soil deposits, it means which has layers of different kind of soils having different values of coefficients of permeability. Show greater magnitude in direction. Options are parallel to stratification, perpendicular to the stratification, inclined to the stratification, or none of these. Next question. What will be the ratio of average permeability in horizontal direction to that in the vertical direction for a soil deposit consisting of three horizontal layers if the thickness and permeability of the second layer are twice of those of the first and those of the third layer twice those of second? Please read the question very carefully. What will be the ratio of average permeability in horizontal direction to that in the vertical direction for a soil deposit consisting of three horizontal layers if the thickness and permeability, this is a condition given over here, thickness and permeability of the second layer are twice of those of the first and those of the third layer. Those means thickness and permeability of the third layer are twice those of the second. Your options are 21 by 7, 3 by 7, 18 by 7, and 9 by 7. What will be the ratio of average permeability in horizontal direction to that in the vertical direction for a soil deposit consisting of three horizontal layers if the thickness and permeability of the second layer are twice of those of the first and those of the third layer twice those of second? The options are 21 by 7, 3 by 7, 18 by 7 or 9 by 7. Next question. Calculate the coefficient of permeability in meter per day of a soil sample 6 centimeter in height and 50 centimeter square in cross sectional area. If a quantity of water equal to 430 ml passed down in 10 minutes under an effective constant head of 40 centimeter. The constant head is given, the time is given, the quantity of water is given, the height of soil sample is given, and the cross sectional area is given. You have to find out the coefficient of permeability in meter per day. Mind the unit, I am asking it in meter per day. Your options are 1.53, 1.65, 1.86 or 1.78. I'll repeat the question. Calculate the coefficient of permeability in meter per day of a soil sample 6 centimeter in height and 50 centimeter square in cross-sectional area if a quantity of water equal to 430 ml passed down in 10 minutes under an effective constant head of 40 centimeter. Your options are 1.53, 1.65, 1.86 or 1.78. Assignment 3. Who is this? Bhavna. Yes, Bhavna. What is your doubt? Assignment means the assignment given by your course coordinator. Uh, Sorry to say, but I am not entitled to solve your assignment problems. Okay, your assignment problem should be solved by you only, exclusively by you only. I am just here to help you with some additional questions and some of the conceptual questions so that you can solve your assignment in a better way. This is just practice sessions, live sessions, and I am not entitled, I am not allowed to solve any of the current year's assignment questions. Okay, you have to find your own way to solve the problem. Yes, so quantity of water is 430 ml passed down in 10 minutes under an effective constant head of 40 centimeter. Yes, Ravi, you have any doubt? Bhavna, I cannot do anything. Okay, these questions are answer option. These are right or not? This question, this current question which I am showing you, Bhavna, and Ravi, you can assignment. I am not entitled to do anything with your assignment questions because your assignment questions has been given to you by your course coordinator. Okay, assignment questions has been given to you by your course coordinator. So I am not entitled. I'm sorry, but I am not entitled to do anything, solve or discuss anything with the assignment questions. And Ravi, yeah, okay, Ravi, you can ask your query if you have any query in the chat box only. Okay, let me finish discussing all the questions. Okay, so I hope I have discussed this question. Next question. 30 minutes almost over here. The line within a dam section below which there is a positive hydrostatic pressure. What is that line called? The line within a dam section below which there is positive hydrostatic pressure. The options are cutoff line, phreatic line, flow line, or pressure line. The line within a dam section below which there is positive hydrostatic pressure. The options are cutoff line, phreatic line, flow line, or pressure line. For those who have joined late, I will be repeating the questions from the compaction once again so that you can solve it within the time I will give later. Next question. Soil at the toe of a dam has void ratio of 0.62 G, that is specific gravity of soil solids is 2.62. Assuming a factor of safety of 5, the permissible exit gradient is. So the soil has a void ratio of 0.62 and specific gravity of 2.62. So if you consider that the factor of safety is 5, then what can be the permissible exit gradient? Your options are 1, 0.5, 1.05 or 0.2. Soil at the toe of a dam has void ratio of 0.62 and G equal to 2.62. Assuming factor of safety of 5, the permissible exit gradient is 1, 0.5, 1.05 or 0.2. Next question. This is once again a multiple select question. More than one options can be correct. Elevation of a point with respect to any arbitrary datum is called. Elevation of a point with respect to any arbitrary datum is called. The options are pressure head, position head, total head, or elevation head. Elevation of a point with respect to any arbitrary datum is called. Your options are pressure head, position head, total head, or elevation head. Next question. In a flow net, there are 4 flow paths and 15 equipotential drops. If the head loss is 3 meter and K, that is the coefficient of permeability, is 2 into 10 to the power minus 5 meter per second, estimate the quantity of seepage in meter cube per second. I repeat, there are 4 flow paths and 15 equipotential drops. The head loss is 3 meter and K equals to 2 into 10 to the power minus 5 meter per second. Now estimate the quantity of seepage in meter cube per second. Okay. Your options are 4.2 into 10 to the power minus 5, 2.2 into 10 to the power minus 5, 1.6 into 10 to the power minus 5, or 4.2 into 10 to the power minus 4. This is a problem of flow net where there are 4 flow paths and 15 equipotential drops. I hope you know the formula to find out the quantity of seepage. Okay, next question. Seepage pressure is, options are, equal to pore pressure, impact pressure of precipitation on soil, pressure exerted by percolating water on the soil, or none of these. Seepage pressure is equal to pore pressure, impact pressure of precipitation on soil, pressure exerted by percolating water on soil, or none of these. Which line fits as a definition of seepage pressure? Next question. This 3. Bhavna, you don't have to tell the answer in the chat box. You write it down. We'll be discussing the answers after a while. Okay. Next question. Yeah. Okay. A homogeneous earth dam is 52-meter high with 2-meter freeboard, having 25 equipotential drops and 4 flow channels. If the coefficient of permeability is 3 into 10 to the power minus 3 centimeter per second, calculate the discharge in meter cube per second per meter length. So we have a homogeneous earthen dam which is 52-meter high and it has 2-meter freeboard. It has 25 equipotential drops and 4 flow channels inside of it. Now the coefficient of permeability K is 3 into 10 to the power minus 3 centimeter per second. Then what will be the discharge in meter cube per second per meter length of the dam cross section? The options are 0.00036, 0.00024, 0.0036, or 0.0024. All the answers are in meter cube per second per meter length of the dam. Okay. Next question. Portion between two adjacent equipotential lines and adjacent flow lines is called. What is the portion which is surrounded by two equipotential lines and two flow lines? The options are field, gap, potential drop, or velocity drop. Portion between two adjacent equipotential lines and adjacent flow lines is called field, gap, potential drop, or velocity drop. Next question. The critical hydraulic gradient for a loose deposit of sand having specific gravity of 2.67 and void ratio of 0.67 is. To find out the critical hydraulic gradient for a loose soil deposit of sand which has a specific gravity of 2.67 and a void ratio of 0.67. The options are 0, 1, 2, or 3. To find out the critical hydraulic gradient, G equal to 2.67 and void ratio is 0.67. Next question. It is a similar question. A hydraulic head that would produce quick condition in a sand stratum. Here to find out the hydraulic head which will give rise to quicksand condition in a sand stratum which has a thickness of 2 meter, specific gravity is 2.7 and void ratio is 0.7. Please mark the words carefully. I have asked you to find out the hydraulic head in this question. Okay, hydraulic head that can produce a quicksand condition in a layer of thickness of 2 meter, specific gravity 2.7 and void ratio of 0.7. Okay. Now for those who have joined late, I'll just repeat the questions of soil compaction. The first question was factors affecting compaction of a soil are. Your options were water content, soil type, compaction energy, or all of these? What are the factors that affect compaction of a soil? The next question was, it was an MSQ for the same soil type. The effect of heavier compaction is to. What is the effect of heavier compaction on a soil? Decrease the optimum water content, decrease the maximum dry density, decrease the effective shear stress, or increase the maximum dry density. What is the effect of heavier compaction on water content, dry density, and shear stress, and or shear stress? Okay. Next question was, water content used in field compaction is known as. What is the water content which is used in field compaction? It is known as optimum water content, field water content, placement water content, or natural water content. Okay, the next question was, the variables concerning the method used to compact a given soil include. Another MSQ, multiple options can be correct. The variables which are related to the method used to compact a given soil. The options are manner of compaction, weight of the equipment, area of contact, or time. Okay. Next question. The line showing dry density as a function of water content in the absence of air void is called. The line showing dry density as a function of water content. The graph of dry density and moisture content in the absence of air voids. The line which shows the absence of air void is called zero saturation line, no air void line, maximum compaction line, or saturation line. Next question. In modified Proctor test, the soil is compacted in how many layers? 2, 3, 4, or 5? The next question was, a soil sample has a specific gravity of 2.7 and optimum moisture content of 16%. What is the theoretical maximum dry density that can be achieved for the soil? The maximum dry density in theoretical aspect that can be achieved for the soil: 0.185, 1.896, 1.885, or 1.785. The last question was, a cohesive soil is the maximum dry density of 1.8 gram per cc at OMC, optimum moisture content of 16% during a standard Proctor test. The specific gravity of the soil is 2.65. So dry density is given, maximum dry density is given at OMC of 16%, and G is equal to 2.65. To find out the void ratio of the soil, the degree of saturation, and the maximum dry density, it can be further compacted too. Alright, so these are the questions. I'll give you some time. You have more questions over here, so I'll give you around 15 minutes. Okay, I'll start at 6:06. I'll give you some time. Okay, I'll start at 6:06. Till then, you people solve the answers and we'll discuss them afterwards. Alright. Hello. Those who are joining now, please wait for another 5 minutes. I have already dictated the questions. I'll be discussing the answers within another 5 minutes. I'll wait for another 2 3 minutes. Let the others join. Okay. All right. We'll start discussing the answers. Am I audible? And is the PPT visible? Anyone? Okay. So the first question was factors affecting compaction of the soil are. What is the answer? Any answer? Yeah, it will be better if you tell the answer. Okay. So I don't have to juggle between the Google Meet and the PPT. Okay. So yes, D. All of this is the answer because uh, this what to say soil compaction is affected by water content, soil type, compaction energy, everything. So all of this is the answer. All the three factors affect the compaction of a soil. Next question was, for the same soil, the effect of heavier compaction is 2. What is the answer? Any answer? For the same soil type, the effect of heavier compaction is 2. This is the graph between moisture content and dry density. This is one compaction curve. Upon increasing the compaction energy, the curve becomes the curve shifts towards the left and up. So what happens? The moisture content it decreases and the dry density it increases. So upon heavier compaction, the first thing is decrease in the optimum moisture content. And the second thing that happens is increase in the maximum dry density. The first and the last option are the correct answer. Okay. Nothing as of now has been told about the shear stress effect of compaction of the shear stress. That will be covered in a separate chapter. Sorry. Next question. The water content used in field compaction is known as. Any answer? Water content used in field compaction. Yes. C. Yes. Placement water content. When it is in field, the compaction is done. The moisture content which is being executed, which is used to execute compaction in the field, is called the placement water content. Next question. The variables concerning the method used to compact a given soil include. Any answer? You can tell the answer, make this session a bit interactive, or else you can just continue giving the answer in chat. There's no issue. Variables concerning the method used to compact a given soil include. If you want to compact a given soil, then the manner of operation will be taken into consideration. How are we operating the compaction? Whether it is rollers, slammers, kneading, pressure, what is the weight of the equipment, that will be taken into consideration. What is the area of contact, also taken into consideration. Yes, all. And for how much time the pressure has been given on the soil. So everything, every variable here is concerned while compaction is being taking place. Okay. So each individual method of compaction will be concerning all these four variables. Next question. The line showing dry density is a function of water content in the absence of air void is called. Any answer about this? Any answer? The line showing dry density is a function of water content in the absence of air void is called saturation line. It is also called zero air voids line. Okay. When there is no air void present, that means upon compaction, all the void is being filled with water. So the soil is completely saturated. Hence, it is called a saturation line, also called a zero air voids line. Next question. In modified Proctor test, the soil is compacted in how many layers? Very easy question. What is the answer? What is the answer? In modified Proctor test, the soil is compacted in how many layers? Yes, yes, good. Modified in modified proctor test, soil is compacted in 5 layers. In standard proctor test, it is in 3 layers. Good. Okay. Next question. A soil sample has a specific gravity of 2.7 and optimum moisture content of 16 percentage. What is the theoretical maximum dry density in gram per cc that can be achieved for the soil? Have you solved this? Has anyone solved this question? Okay. So we know the formula of dry density is rho d equals to g rho w divided by 1 plus E, where E equals to moisture content W G by S. Now, to achieve this max, that is maximum dry density, for that the soil should be compacted such that there is no air void present. In other words, the soil is completely saturated. For that, S should be equals to 1. So, it will be G, I'm sorry, it will be rho. It is rho. Because I am using rho d, I should use rho w. G rho w by 1 plus wg by s. I'll write only w and g. S is equals to 1. So g is given over here 2.7. Rho w is 1 gram per cc, density of water. Moisture content is 16% or 0.16. Okay, you put these values in this equation, you will get the value of the maximum dry density as 1.885 in gram per cc. Okay, so this is the answer. This is the basic formula in the chapter of India's properties of soil, how to find out dry density or dry unit weight from the void ratio and specific gravity. Using this equation, for maximum dry density we have to consider saturation equals to 1. So rho d max equals to 0 w by 1 plus wg. I hope it is clear. Okay. Yes. So next question was, yes, the last question. A cohesive soil yields a maximum dry density of 1.8 gram per cc at an optimum moisture content of 16% during a standard proctor test. Specific gravity is 2.65. Have you solved this question, anyone? Void ratio 0.424. Void ratio is 0.424. Okay, let's see. For void ratio, you have to use the same formula. Rho d equals to G rho w by 1 plus E, from which E equals to, it becomes G rho w, it becomes G rho w by rho d minus 1. Put the value, rho w equals to 1, G 2.65, rho d equals to 1.8. I think you'll get a value of 0.4722. I'll solve once again. G is 2.65, 2.65 divided by 1.8 minus 1. Yes, the void ratio is 0.4722. Okay. Now degree of saturation, we all know that E equal to Wg by S. E equal to Wg by S, or we can write at once S equals to Wg divided by E. Okay, W is 16%, that is 0.16 into 2.65 divided by 0.4722 into 100%. To convert it to 100%, we are getting the value of 89.79 percentage. 89.79 percentage. Okay, and for the maximum rate density, again we have to use the previous formula. Rho d max equals to, you have to consider, the question is the maximum rate density, it can be further compacted too. So for that we do not need to consider the degree of saturation given over here. To consider the saturation degree equals to 100% or 1. So in that case, it is equals to G rho W divided by 1 plus WG. W is 16 percentage, G is given 2.65. So putting the values, I'll be getting 0.16 into 2.65 plus 1 and 2.65 divided by answer. I'm getting 1.861. Yes, I'm getting 1.861 gram per cc. I hope it's clear. These are the three answers. Yeah. So you have to use these three separate formulas. These three separate formulas for this three separate parts of the same question. Okay, so compaction is done. Now we go to the seepage and permeability part. Okay. Seepage velocity is, what is the definition of velocity? Anyone? What is seepage velocity? Okay, no answer. It is the rate of discharge per unit cross-section area of voids. Okay. When we are considering per unit cross-section area of soil, this, then it is called discharge velocity. Discharge velocity. Okay. So seepage is considering the void in the soil and not the entire cross-section of the soil. Next question. Soil has a discharge velocity of, yes, and void ratio of 0.5. Seepage velocity is, any answer? Anyone? Okay. So here the void ratio is given. First, we have to find out the porosity from the void ratio. Why? Because of the previous question, that is, it is the area of the cross section of the voids we consider. So we have to first find out the porosity. We can also use the void ratio, but better to use the porosity. It becomes simple. N is equals to E by 1 plus C. What is the value of N? 0.5. 0.5 by 1.5. It is 0.333. Something like this. Okay. Now You are asked to find out the seepage velocity, right? So seepage velocity, the formula is equals to discharge velocity, actual, that is V divided by porosity. Now you do this, divide 6 divided by 0.333, get a value of 0.333, 18.18, I believe, second to the power minus 7. Please solve this question. Yes, B is the right answer. 6 divided by 0.33. Yes. You take this up to 2 decimal places, okay? Take this up to 2 decimal places as is customary for this kind of numericals, and then you get the value of 18.18 into 10 to the power minus 7 as given in the question, meter per second. Okay, so this is the answer. Vs equals to V by N. N is the porosity. This is the formula. Okay. All right. Next question. Flow between any 2 points in a soil depends on the difference between. What is the answer? It's an easy question. Please tell the answer. Any answer? Total head or pressure head? Flow between 2 points. If somebody is saying pressure head, then what about the velocity head and datum head? You add everything. You add pressure head, velocity head, and datum head. Then you get total head. Total head is responsible for the flow between 2 points. Because the water is flowing, it has a particular velocity. So it will have a particular energy or head with respect to its velocity. If the soil is in a particular height, at a particular height, it will have energy with respect to its height, with respect to its elevation. That is called datum head or position. Okay. So everything will add up to give the total head, and that will be responsible for flow between any 2 points in a soil or in any medium whatsoever. Clear? Okay. Next question. Falling head test. Has anyone solved this question? Has anyone solved this question? Falling head test. How to solve? First, you will find out the area of cross section of the soil sample. What is the formula? Area is pi by 4 into d square. D is the diameter of the soil sample, 80 mm. Find out the value in cm square, centimeter square. I think you will get 50.265, something like this, centimeter square. Okay. Next, find out the area of the cross section of the standpipe. Same, pi by 4 small d whole square. Small d is how much? Small d is 4 mm. Again, find out this area in terms of centimeter square. I think you will get 0.126 centimeter square if you solve it now. 0.126 centimeter square. Now, the formula of falling head test, K is the coefficient of permeability, equals to 2.303 small a into L, length of the soil sample, divided by capital A, area of the soil sample, into small t, time taken. By 80 log to the base 10, then H1 H1 divided by H2. Okay, solve this. What is the answer you're getting? Please tell me. H1 is the initial head, that is 1200 mm. H2 is the final head, that is 400 mm. Small a is the area of the cross section of area of the standpipe, cross section of the standpipe, and capital A is the area of the soil sample. Length of the soil is 12 centimeter, and time is uh, is given in minutes. You have to convert the time in seconds, that is 6 minutes into seconds, and then the answer will come in centimeter per second. Just convert the time in seconds. Okay, and the length is already given in 12 centimeter. Now give me the answer. What is the answer? Anyone? The answer which I am getting, the answer which I am getting is 9.181. That is this one. 9.181 10 to the power minus 5. Please check and confirm. You can take a screenshot of this and then check and confirm it afterwards if you like. Okay. Next question. I hope you have understood the question. Permeability in stratified soil deposits show greater magnitude in direction. What is the answer? Stratified soil deposit means the soil is having, this is the thickness of the soil, it is separated into layers, where each layer will have a different value of K. Okay, so in this case, the permeability will be maximum in which direction? C, inclined. Is this the answer to this question or the previous question? 14. Slide number 14. Yes, C. No, not C. See, when water has to travel like this, it will have more resistance, or traveling like this will have more resistance. Obviously, traveling like this or traveling like this will have more resistance. Okay, because why? Because when we are finding out permeability parallel to the certification, then we use the formula of arithmetic mean. K average equals to K1 Z1 plus K2 Z K1 Z1 plus K2 Z2 plus dot 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 up to, and the total thickness of Z. For this case, what do we do? We use a harmonic mean, that is K average K average is equal to first the thickness Z, then divide by Z1 by K1 plus Z2 by K2. Okay, and as we know, arithmetic mean is always more than harmonic mean. Arithmetic mean is always more than harmonic mean. So in this case, arithmetic mean is followed in the flow where the in the case where the flow is parallel to the certification. Hence, permeability will be more where K is more. So it will be K is greater in direction parallel to the certification. Is it clear? Yeah, good. Parallel is the right answer. This question. Ratio of average permeability in horizontal direction to that in the vertical direction. Soil deposit 3 layers. Thickness permeability of the second layer are twice of those of the first and those of the third layer. Twice of the second. Any answer for this? So what is said over here in the first layer, it is nothing mentioned. So we'll consider it as consider the value of coefficient permeability as K and the thickness as Z. It is said now thickness and permeability of the second layer twice of those of the first. So for this it is 2K and 2Z. 2Z. Okay. And those of the third layer twice of second. So it is twice of 2K, that is 4K. And 4Z. Okay. Now you find out K horizontal in the previous formula. K horizontal. What is the value of K horizontal? K1 Z1 K2 Z2, that is KZ plus 4KZ plus 16KZ. KZ plus 4KZ plus 16KZ divided by total Z, that is 7 4 plus 2 7Z. It gives us what? 16 plus 4 20 plus 1 21 by 7K. Just 21 by 7K. Now do the same for vertical. K vertical. It is thickness by the ratios, that is 7Z whole divided by Z1 by K1, Z by K, 2Z by 2K, 4Z by 4K. In other words, 2 gets cancelled, 4 gets cancelled. It is, okay, I'll write it down. Z by K plus 2Z by 2K, that means Z by K only. Again 4Z by 4K, that is Z by K only, isn't it? So it is 3 into Z by K. ZZ get cancelled, so it is how much? Hello, are you following? So it is how much? It is 7 by 3, isn't it? K. Please repeat. Okay. See, it is a stratified deposit. It has 3 layers, layer 1, layer 2 and layer 3. Layer 1, I consider the value of thickness and permeability to be Z and K. Now I have said in the question that in the second layer it is twice of those of the first layer. That is K becomes 2K, Z becomes 2Z. Now in the third layer it is twice of the second. That is 2K becomes 4K and 2Z becomes 4Z. Right? It is twice of those of the second layer. So this is K and Z, it is 2K and 2Z, it is 4K and 4Z. We have the value of permeability and thickness. Now we have to find out the ratio of average permeability in the horizontal to the vertical direction. I have mentioned in the previous question the horizontal what to say average is the arithmetic mean, and the vertical is the what? Harmonic mean. Okay, so first of all, find out kh, horizontal. Arithmetic mean, that is k into weighted arithmetic mean, k into z plus 2k into 2z plus 4k into 4z. That is kz plus 4kz plus 16kz divided by the entire thickness, that is 7z. We get 21 by 7k. Okay, now we find out the k vertical, that is the harmonic mean. Thickness divided by the ratio of thickness to permeability, z by k, plus in the second case it is 2z by 2k. So 2 gets cancelled, it is again z by k. In the third case it is 4z by 4k. So 4 gets cancelled, again z by k. So we get 3z by k. So gets cancelled, we get 7 by 3k. Right? Now we find out the ratio. Ratio of kh is to kv. It will be how much? 21 by 7 into 21 by 7 into 7 by 3 reciprocal, that is 3 by 7. 7 into 3, 21. 3 is a 9. So you get 9 by 7. Yeah, good. So we get 9 by 7. Okay. The answer is 9 by 7. Okay. So this is a very important thing to keep in mind. For horizontal permeability, average is the arithmetic mean, and for the vertical it is the harmonic mean. Okay. Now, next question: calculate the cross coefficient of permeability in meter per day of a soil sample 6 centimeter in height and 50 centimeter square in cross sectional area if a quantity of water equal to 430 ml passed down in 10 minutes under an effective constant rate of 40 centimeter. Has anyone solved this? Anyone? Okay. We know Q equals to KIA. Q means discharge per unit time. K I means H by L, head difference divided by the length of traverse, and A is the cross sectional area. Now, what can we do over here? We have Q. What is the amount of water? Quantity of water 430 ml means 430 cc. 430 ml is 430 cc. The time is 10 minutes. Convert the minutes into second, or you can convert the minutes into day because I've asked you in meter per day, right? You have the soil sample of 6 centimeter in height and 50 centimeter square cross section area. Okay, so A is 50, value of A is 50. The head, okay, the head is 40. The head is 40, and the length of the soil sample is the height of the soil sample is 6 centimeter. Now you rearrange this equation. K will be equals to how much? Q into L divided by time into head into area. Okay, you put this value, all the values, whatever the units are given over here. Okay, now for the time is in 10 minutes. You have to convert 10 minutes to days, number of days. So 10 minutes is 600 seconds. You put time as 600 seconds over here, and then you multiply by 24 into 3600, this whole thing. Again, Q you are finding out in 430 cc, length is in centimeter, head difference is in centimeter, area is in cm square. To convert this entire thing into meter, you have to divide by 100. You do this, you and tell me the answer. What is the answer? Anyone getting any answer? Anyone? All right. I'm getting the answer C. Option C. 1.86 meter per day. Okay. I am taking Q equal to 430 cc, 430 L. Okay, L is 6, T is 10 minutes, or better, I'll take T as 600 seconds and then convert the time 24 into 3600. Head difference is 40 centimeter, area is 50, and then convert the entire thing into meter by divide by 100. So put the values over here and then convert it, you will get 1.86. Okay, I hope it's clear. Is it clear or should I repeat? Okay. Okay. Next question. The line within a dam section below which there is positive hydrostatic pressure. What is the line called? Any answer? B. Phreatic line. Yes. This is a dam section, upstream side and downstream side. Then this is the upstream side, then this is the water level, the downstream side, this is the water level. There is a line of flow, the first line of flow of water. Above it is dry. This is positive hydrostatic pressure. Okay. This line is called the phreatic line. Clear? This is the upstream side. This is the downstream side. Good. Next question. Soil at the toe of a dam has void ratio 0.62 and specific gravity 2.62. Assuming factor of safety of 5, the permissible exit gradient is. Have you solved this question? So basically, the numericals are not being solved by anyone. Okay. Okay. Critical exit gradient. I see the value. The formula is G minus 1 by 1 plus E. Yes, I believe I have some. Need more time. Okay. Actually, the questions. These questions, they are very small. Actually, there's these numericals. Okay, I've given time almost 15 minutes time. These numericals you could have solved at first because these are more important. Okay, so you put this value G and E. I think you'll get a value of 1. I believe 2.6 to 1.62. Yes, value of 1. So this is the critical exit gradient. Now the permissible gradient should be less than this because we will not be keeping the gradient till the critical gradient. So the permissible gradient, so factor of safety is what? Factor of safety is the ratio of critical gradient by permissible gradient. So permissible gradient will be critical gradient by factor of safety. Other words, 1 divided by 5, it will be equal to 0.2. Clear? Permissible gradient is the gradient which is acceptable in case we are not considering any piping failure in the soil because of the seepage, upward seepage of water. So critical gradient, that is at this gradient there is a 50-50 chance it might fail or not fail. The factor of safety is 1. So we have to keep it lower than the critical gradient to get a factor of safety more than 1. In this case it is equal to 5, hence it is 5 times less. Clear? Alright, next question. Elevation of a point with respect to any arbitrary datum is called. More than one answer can be correct. What is the answer? C. Only C. C is total head. I'm asking about elevation. I'm asking about elevation. Total head is a summation of pressure head, datum head, and velocity head. But the head which is due to the elevation of a point, what is it called? It is called position head, and also it is called elevation head. Okay. Pressure head is due to the water pressure, and total head is the summation of all the pressures: velocity head, pressure head, and elevation head. Next question. In a flow net, there are 4 flow paths and 15 equipotential drops. If the head loss is 3 meter and K is equals to 2 10 to the power minus 5, estimate the seepage quantity of seepage. Have you solved this question? The formula is Q equals to K H N F by N D. K value is given, H head loss is 3, head loss is 3 meter, NF number of flow paths or flow channels, it is equals to 4, and ND number of equipotential drops is 15. Put this value, you get C as the answer, 1.6 10 to the power minus 5. Okay, 4 by 15 into 3, 4 by 5, 4 by 5, 4 into 2, 8 by 5, 5 into 1, 5, 30 and 6, yes, 1.6, 1.6 meter cube per second. Clear? We have another sum like this. Okay. Seepage pressure is, what is seepage pressure? What is seepage pressure? Anyone? It is the pressure exerted by percolating water on the soil. Okay. This is the cross section of the soil. Then these are the voids in the soil particles. If you see from the side, the water is percolating over here like this. That pressure exerted by the water on the soil is called seepage pressure. It can be also in upward direction. Next question. Homogeneous earth dam 52 meter high with 2 meter freeboard having 25 equipotential drops, 4 flow channels. Again the same question, but here the head is different. Head is equals to 52 minus 2. Why? Because this is an earthen dam. This is the water level. Okay, there is no water on the downstream side. This is 52 entire height and this is 2 meter. So the actual head, that is H, is the level of water on the upstream side. This is 50. Again the same formula, Q equals to K H NF by ND. Here NF is 4, number of flow channels is 4, and ND is number of equipotential drops, it is 25. Put the values over here. D, you're getting D. B, yes, B is the answer, 0.00024 meter cube per second per meter length of the dam. Yes, B is the correct answer. Okay, I hope it is clear. Anyone else? No, Venkat only. Okay. Next question. Portion between two adjacent equipotential line and adjacent flow line. If these are the two flow line and this is two equipotential line, what is this portion called? It is called a field. Yes, someone gave the answer. A. Yes, field. It's called a field. Okay. Last two questions left. Critical hydraulic gradient for a loose soil deposit of sand having specific gravity and void ratio. Very easy question. Critical hydraulic gradient, that is IC, equals to G minus 1 divided by 1 plus E. G minus 1 by 1 plus E. G is almost 2.67 minus 1 1.67 divided by 1 plus 0.67 is 1.67, gives the value of 1. Okay, so this is the answer is 1. Next question, similar thing, the hydraulic gradient. Okay, the hydraulic head that will produce a quick condition. For producing a quick condition, we need the critical hydraulic gradient, because if it is more than the critical hydraulic gradient, only then piping will occur, quick condition will occur. So first of all, we need to find out the critical hydraulic gradient the same way like the previous question. G minus 1 divided by 1 plus E. We have, what do we have? G is 2.7 minus 1 1.7 divided by 1.7 is 1, isn't it? That is 1. Critical hydraulic gradient is 1. Now IC equals to how much? That is the head difference divided by L. Okay, head difference divided by L. Now this head difference is the hydraulic head. This is the hydraulic head. So H will be equals to how much? IC into L. Now what is L? L is the length of the traverse of the water. Okay, what is the length of traverse? The length of traverse is the thickness of the soil sample. Why? Because if this is the thickness, then the water has to go like this. Seepage in upward direction has to occur for quick condition to take place. So this is the length of traverse. Okay, it is 2. So 1, IC equals to 1, L equals to 2, value is 2 meter. So the hydraulic head is 2 meter. A 2 meter hydraulic head would produce a quick condition in this kind of soil. Clear? Is it clear? Yeah. Okay. Okay. So any question regarding this session? Any doubt? Some of you have left the meeting already. Okay. Yes, who is it? Well explained, and thank you for patient explanation. Okay. Thank you, and thanks for the interaction. Whatever you have given the answers in chat, it was good. Okay, so if there is no doubt, I'll be ending the session now. We'll be meeting again on the coming Sunday at 5 p.m. Okay.